This is your video for your Unit 10 study guide. So an infinite series has an nth partial sum. For this, what is the sum of the series? So we're just going to take that limit out to infinity for this partial sum. And since these are both n to the first, they're the same, we're going to use the coefficients, and so it'll just be 3/5. Now this next section, they're all geometric. So determine if it converges or diverges, and if it converges, then find the sum. So what we want to find is the first term and the r value. So in this case, first term is 4, and the r value is what you're multiplying by to generate the pattern. So it's alternating positive, negative, positive, negative. So I know this is going to be negative, and it looks like it's staying 4 on the top, so -1, and then we're multiplying by 3 on the bottom. And I'm sorry, I should have said the absolute value of r. We need to look if that is bigger or smaller than 1. So absolute value of r would be 1/3, and that is smaller than 1, so it's going to converge. So it converges because 1/3 is smaller than 1. And so if it converges, then we're going to actually find the sum. So you have to memorize the formula. It's the first term, which is 4 over 1 minus r. And we do want to simplify these down. So that would be 4 over 1 plus 1/3 would be 4/3. And then we're going to multiply by the reciprocal. The 4s are going to cancel, and so we just get 3. Now this one is kind of set up nicely for us. Our first term is 5, and r is 7/3. So since 7/3 is bigger than 1, this is going to diverge. So for this next one, actually, both of these, it's hard to tell it's geometric just from looking at it. So we want to kind of generate a few terms in the series. So we're going to start with n being 1 and plug that in. So up here, we would get 3 squared, which would be 9. And down here, we would just get 4. So 9/4 is our first term. And now I'm going to plug in 2. So that would be 27/16. And if I plug in 3, I'm going to get 81/64. And you usually only need 2 or 3 terms really to see what's going on here. So first term is 9/4 and r is 3/4. So it converges because 3/4 is smaller than 1. And if it converges, then we're actually going to find the sum. So it'll be the first term. So the 9/4 over 1 minus r. So we want to simplify that down. It'll be 9/4 over 1/4. And those 4s are just going to cancel, and we get 9 over 1, which is just the same. So same thing with this one. You want to generate a little bit of the pattern so you can see that it's geometric. So if we plug in 1, we're going to have -1 over e to the 3rd for our first term. If we plug in 2, that's going to make that positive. Oh, it'll still be 1 though. Over e to the 4th. And then if we plug in 3, it's going to be negative again. So this is alternating over e to the 5th. And again, you only need a couple terms to see what's going on. So our first term is this one, -1 over e to the 3rd. And r is -1 over e. We're multiplying by -1 in the numerators and e in the denominators. So e is about 2.7. If you even just want to round that to 3, think of this as -1/3, we would absolute value it. It would be 1/3. And so that is smaller than 1. So this is going to converge. And so we're going to actually get the answer. So it'll be the first term over 1 minus r. And so to simplify that down, this would be plus, and if you think of the 1 as e over e, you would have e plus 1 over e, and then I'm going to multiply by the reciprocal. So we're just going to flip this over. And then you really can't do too much with that, except one of these e's will cancel. So your final answer would be -1 over e squared, and then times this e plus 1. So I'm just multiplying the 2 fractions together, and one of the e's canceled out. So for these next ones, it's the nth term test for divergence. So you do the limit as n goes to infinity, or in this case, these are both with k instead of n. The letter doesn't really matter. You do the limit to infinity, and if it equals anything other than zero, anything in the world other than zero, then it's going to diverge. If it equals zero, that doesn't tell you that it converges. That would be no conclusion, but we can find out whether or not it diverges. So we're going to do limit as k goes to infinity of all of this. So since these are the same, we're going to use the coefficients, which would be 2 over 1, which is 2. And since that's not 0, we're going to say it diverges. Because the limit is not 0. So anything else in the world that's not 0. So same thing for this one. So this one's a little bit tricky. The numerator is a polynomial. If you have, k squared or k to the third, k to the fourth, k to the fifth, that's a polynomial. This one, oh, that should be a k there. This one is exponential. Our variable is the exponent. So an exponential is going to grow faster than a polynomial. So the denominator is getting larger, way faster than the numerator. And so this is going to go to 0. And so we would say no conclusion. Which I cannot write today. Because the limit is 0. All right, so these ones are p-series. And so you have to remember that that's opposite of geometric. For geometric, when you look at the R value, it needs to be smaller than 1 to converge. For the p-series, it needs to be bigger than 1 to converge. So in this case, p is 1/5. This would be n to the 1/5 power. And so that diverges. So it diverges because 1/5 is smaller than 1. And for this one, p is 5. And so that's bigger than 1, so converges because 5 is bigger than 1. So you're just saying, is it bigger or smaller than 1? All right, and then these are used the integral test. So if the integral converges, then so does the series. Not specifically to the exact same thing. We're not actually finding the sum. The geometric ones are the only ones where you actually really find like an answer. For the rest of these, we're just saying, does it converge or does it diverge? So this will be limit as b goes to infinity, integral 1 to b. And when you write this, you just write it with x's. So e to the negative 1/2 x. That negative in the fraction kind of really got mixed together there. But it is a negative 1/2 there, and then dx. So this would be a u substitution, but I usually just encourage everybody to like do the adjustment if it's a real simple one. To adjust for the negative 1/2, you would put a -2 out front. And then it is upper boundary minus lower boundary. And you just keep that limit out front the whole time until you actually evaluate the limit. So if you plug in b, this negative is going to bring that back down to the denominator. So it would be e to the 1/2 b, except in the denominator since it's a negative exponent. And then if you plug in 1, you would have -2 over e to the 1/2. And then finally, we're going to evaluate the limit. So you set it up, you do the antiderivative, you do upper boundary minus lower boundary, and then we're going to evaluate the limit. So as b gets larger and larger and larger, this denominator is going to be huge. So this part's going to go to 0. These negatives cancel. And so that is just your answer, 2 over e. Well, actually, I should say that's not your answer. We got an answer. And so the test tells us that this series also converges since we got an answer, not specifically to this value, but since we got an answer here for the integral, the series is also going to converge. So it converges by integral test. And then we're going to do the same thing for this one. So limit as b goes to infinity. And so you want to think of this as 1 over x. It's just there's a 1/2 in front of it. You could even write the 1/2 in front of the integral if you really wanted to. But it is going to be an ln. So this will be 1/2 ln of x such that 1 to b. And then we're going to do upper boundary minus lower boundary. Ln of 1 would just be 0. So that's going to go away. And then lastly, we evaluate the limit. If you think of this going to a very, very huge number, it's going to go upwards to infinity. Your ln graph goes like this. So that's going to just keep on going up. This is like what your ln graph looks like here as an asymptote and goes like that. So since we did not get an answer, since this diverges, then so does the series. And that's really all that this unit is. We have geometric, we have p-series, we have the nth term test, and we have the integral test. So those are all the tests that we've done so far. I do have a section on the test that has them mixed up. So here I have them like these are p-series and these are geometric and these are nth term. I do have one section where they're mixed together, so you have to be able to tell the difference between them. And so when you give your reason, you would just say, the series is a p-series, p equals whatever, it converges or diverges because that's bigger or smaller than 1. Or you would say the series is geometric, r equals this, and then it converges or diverges based on whether that's bigger or smaller than 1.